Alright students, welcome to the next lesson of our linear unit. This is lesson number 3 out of the 4 for the linear part. And then after we've done this, we'll move on to bivariate data once again and understand how it all connects. So today our lesson is focusing on chapter 1F, learning how to graph a straight line. So your learning intention is, like I said, graphing a straight line from a linear equation. We all know what a linear equation is, or an equation at the very least. But from that, we will be able to hopefully identify points along the line and link them to a table of values. So we've seen these before. Also be able to determine the gradient from a line and from an equation and a graph. Also be able to sketch linear graphs using the gradient intercept method and also the other method, which is also the x and y intercept method. And from there you'll also be able to understand what an x and y intercept is. Alright, so as a starting activity, before we get straight into the actual lesson, we need to understand how to read coordinates. So maybe I'll quickly recap and write down some of how we understand these coordinates. So even before that, actually understand as well what these lines here, so this horizontal and this vertical line, these are your x and y axes. Okay, so whenever we see this, it's what we call a Cartesian plane, and it's got two axes, the x and the y axes. It's basically a number line that has numbers on the horizontal and the vertical. And whenever you see coordinates and dots on the Cartesian plane, there's a certain way that we read the coordinates. So for example, this point here, or coordinate A, okay, this is called the name for this point is -4, 5. Okay, and the reason it's called -4, 5 is it's -4 on the x-axis. See how it lines up there? And it's 5 on the y-axis. Okay, so always call it by the x-axis point and then the y-axis point. Let's look at point B. For example, point B is right here. Okay, so point B is -5 on the x-axis, but it hasn't gone up or down. It's just stayed on 0. Okay, so it's -5, 0. And notice how this is what we call an x-intercept, because this point stays on the x-axis. Okay, point C right here, down here, it's -2, -3. Okay, because it's gone in the -2 on the x-axis, and then right there, and then -3 on the y-axis right there. D would be -4, -4. Okay, right there. Even though, notice how the graph doesn't have the same scale, but it's the same number. Just keep that in mind. Okay, so the way you scale your graph also matters. I won't go through all of them. I might just go through one more. Let's go through E. Okay, E is 0 on the x-axis because it's lining up right there, and then 4 on the y. Okay, so 0, 4. That's what we call a y-intercept. All right, and we'll do one more. We'll do I. Okay, I is 3 and then -2. Okay, so 3, -2. Okay, and the answers are all there, I believe. So I'll just get rid of all this. But yeah, hopefully that's made sense so far. Okay, let's move on. So as an introduction to our lesson, the relationship between two variables in a linear equation, x and y. So whenever you have a linear equation, you're referring to these two variables, can be represented on a linear graph. A linear graph is a straight line that is drawn on a Cartesian plane, like I mentioned before. This is a grid system that is used to plot the coordinates x and y. So everything that we saw here, okay, entails what I just mentioned. So you've got a Cartesian plane, you've got coordinates, although the only thing you don't have is a straight line, but we'll get to that. So the general equation for a linear graph, so these are the things that you need to understand. Equation for a linear graph is this: y equals mx plus c. okay, where m is the gradient or slope of the graph, so that's this guy right here, and c is the y-intercept, so where the graph hits the y-axis. Okay, so I remember in the previous graph here, I mentioned to you guys what a y-intercept was. See this here? This is going to be a y-intercept if there was a line that went through it, okay, because it intercepts the y-axis. For one particular graph, this value does not change. Okay. Note that x and y are coordinates along the linear graph. So x and y, and what that refers to is the x and y in the equation. This x and this y. Okay, they are coordinates along the line of the linear graph. Okay, their values can change depending on the point in the graph you're identifying. So these variables here, x and y, will change depending on the coordinate that you're using. Okay. Keep that in mind. The only things that don't change here are the intercept, the y-intercept, and the gradient. All right, let's look into an introductory task. So equations, tables, and values of graphs. How do we link all of this? So here's a scenario. Oliver works for a company selling furniture. He gets paid a base salary of $80 per week, plus $30 for every piece of furniture he sells. So this guy will always get paid $80 per week, regardless of what he does or how much he sells. Plus, he'll get $30 every time he sells a piece of furniture. All right, so keep that in mind with this scenario. So we need to do three things. Create a linear equation to calculate his wage. If we want to figure out his wage for, say, 10 pieces of furniture sold, 20 pieces of furniture sold, or whatever number of pieces of furniture. We also need to make a table of values to represent the situation and then sketch this in a graph where we're going to put furniture in the x-axis and how much he gets paid on the y-axis. All right, so a lot of this might be a little bit of gibberish to you guys, but we'll make sense of it as we go through the example. So we need to create a linear equation that represents this amount, basically this scenario where he gets paid $80 per week, plus $30 for every piece of furniture. So remember that in the equation, x refers to the amount of furniture that he's going to sell. So the independent variable here. Now, this x, okay, refers to, like I said, the amount of furniture he's going to sell. So that's going to change. Y, okay, is going to be basically representing how much money he'll be earning. So going back to that equation of y equals mx plus c, okay, this is the format of what your equation should look like, okay? So y is going to be how much he makes, x is referring to how much furniture he's going to sell, and the base salary or the constant is going to be this c. It's not going to change in terms of, in relation to x and y, okay? It's going to stay the same. M refers to, you could say M is the amount that he will be, you could kind of say it's the gradient, but also it's the amount of furniture he'll sell, amount he gets for each piece of furniture he sells. All right, so what we need to do from there is basically just substitute the values that we know. We know that M, okay, refers to, like I said, the amount that he makes for each piece of furniture. So that's going to be this. C is going to be the amount he makes regardless of how much furniture he sells. So it's going to be the base salary right there. So that's the 80. So let me make that a bit more clear. So M, it's this piece of information right here. And for the C, or the constant, it's this information here. So you're only really changing two numbers on the formula. The M and the C. Okay, the gradient and the y-intercept. Okay, remember what y represents? Y represents the how much he's going to make, and x represents the how much for pieces of furniture he's going to sell, and every time he makes a piece of furniture, he'll get $30. All right, so there's the formula. Now we're going to make a table. Okay, using the equation, we're going to substitute the number of pieces of furniture sold into to determine how much his wage is. So when X equals 0, which means that if he sells no furniture, okay, Y is going to equal 80. So remember, Y represents how much money he makes. So if he sells no furniture, he's going to make 80 bucks. If he sells one piece of furniture, okay, so if we change X to 1, so 30 times 1, it's going to be plus 180. It'll equal 110. So if he sells one piece of furniture, we're going to add $30. So you can see how from 80 to 110, you've added 30, okay? And then if he sells two pieces of furniture, okay, you're going to add another 30, okay? And notice how every piece of furniture he sells, it goes up by 30. So if he sold two, he's going to make $60. Whereas if he sold none, he'll make $80. So if you put it together, 60 plus 80 equals 140. And then we represent that in the table. So to get three pieces of furniture, it's going to be, for example, this one right here, Y equals 30 times 3 plus 80. Okay, this one here, Y equals 30 times 4 plus 80. And this one, in the fifth one, would be Y equals 30 times 5 plus 180. And then so on and so forth. So you can see that what changes is the X variable, and then the Y is the outcome. All right, sketching a graph of the linear relationship. Here it is. Okay, we've graphed it already. So what links can we see from the graph and the equation? So if you look at the equation, remember Y equals 30x plus 80. 80 refers to how much he'll make regardless if he sells nothing. So you can see there, if he sells no furniture, he's going to make 80 bucks. If he sells one piece of furniture, remember he'll make 110. If he sells four pieces of furniture, he'll make 200, sorry. If he sells 8 pieces of furniture, he'll sell 320. He'll make 320, so on and so forth. Okay, so it goes up by 30 each time. And notice how it's a straight line, which means it's a constant, okay, as in it's adding the same amount each time. Okay. All right, so let's get into sketching our linear graphs. We're going to look at two methods as to how we sketch our linear graph, the gradient intercept method and the intercept method. I should probably call this the X and Y intercept. Okay, this is called that because you're actually using the X and the Y intercept. So 2 points where the basically the line hits the X axis and where the Y hits the Y axis. The line hits the Y axis, sorry. And then the gradient intercept method refers to the gradient and then the Y intercept as well. So let's get into it. First one is the gradient intercept method. This method's pretty straightforward. It uses the Y intercept and the gradient to determine a second point. So you've got one point at the Y intercept, and then the other point is based on what the gradient is. All right, so let's start by understanding this. So for the gradient and intercept method, the Y intercept, the point at which the line meets the Y axis. Okay, so for example here, you've got a line, Y intercept is right there. Okay, the Y intercept in this case, okay, is 0, 4. Okay, 0, 4, that coordinate right there. And then from there, we use the gradient. So the gradient, M, is a number that describes the slope of the line. And the gradient can be calculated using this. We'll actually be learning about this a little bit more later on. And also gradient is referred to the rate of change of Y. So it tells you basically how much it goes up and down by each time with respect to X. So here, for example, the gradient, okay, can be measured by the run and the rise. Mix that up. So this is the rise, how much it goes up and down by, and this is the run, how much it goes left and right by. Okay, in this case, it's always just going to be right. All right. So the bigger the magnitude of the gradient, the steeper the graph. So what that's saying is the higher the gradient, the more steep the graph is going to look. Okay, the lower the gradient, the more, well, the less the incline of the graph is going to be. The gradient of the line can either be positive or negative as well. So positive lines go upwards, negative lines go downwards. Okay, just like what you see here. Negative line, positive line. You also see these lines here, 0 and undefined. 0 lines are basically flat lines, so there's no gradient. An undefined line is basically a straight vertical up and down line. Alright, so as we know, the gradient and intercept form a straight line, which is y equals mx plus c, where m is the gradient and c is the y-intercept. So remember, that's what these represent. M being the gradient, c being the y-intercept. So what we want to do for now is for each of the equations in the table below, let's identify the gradient and the possible rise and run, and then the y-intercept. Okay, so for this first one here, remember what the gradient is. The gradient is going to be that m, which is next to the x, and the y-intercept is that number by itself. So in this equation, the gradient is 3. Okay. Now the possible values for the rise and the run, okay, there's multiple ones. And how did we get that? Well, you can think of it as basically getting that number 3 by dividing the top number and the bottom number. So in this case, 3 divided by 1 equals 3. 6 divided by 2 equals 3. 12 divided by 4 equals 3. What I like to do is, if it's a whole number, just put it over 1. So the possible rise over run for this is just 3 over 1. Okay, I think that makes it easier. The y-intercept in this case, remember the y-intercept is that number by itself, so it should be 2. Okay, for this next one, okay, the gradient is negative 4. Okay, the possible rise and run value as well, if it's just a whole number, just put it over 1. Okay, so in this case, it's negative 4, 1. And then the y-intercept in this case is that number by itself, which is just 1. And then for this one here, the gradient is that number next to the x. Now you don't see 1, but remember there's an imaginary 1 in front of that x. So if the gradient is just a whole number 1, put it over 1 to get the rise over run. So in this case, the possible rise run values are 1, 1. Y-intercept right there, number by itself, negative 12. Here the gradient I can see is that number next to the x, so it should be 4. So if it's a whole number, remember the rise over run is just going to be 4 over 1. And then there is no number by itself here, so that means that the y-intercept is 0. Alright, so now that we know our y-intercepts and our gradients, which is the rise and run values, we can sketch the linear graph. Alright, so let's look at one example here with this graph. So for this one, okay, I know that the y-intercept has to be 2. Okay, so that's pretty easy. Now the gradient is going to be 3. Okay, but remember, if it's just a whole number, put it over 1. Okay, so start off by putting your y-intercept in here. So the y-intercept is 2. Okay, right there. The gradient, so that's 1 point. The gradient is going to be 3 over 1. So it's going to be 3 for the rise and 1 for the run. So on my graph, what I like to do is I'm going to go from that y-intercept, 1, 2, 3 for the rise, and then the run is 1. Okay, right there. So that means my second point is right there. And there is my 2 points. So from there, I can draw my line. So if I can draw this nice and straight. No, it's not straight, but there you go. All right, next one. Let's try negative 3x plus 1. So in this case, my y-intercept is 1, and my gradient equals negative 3. Now remember, if it's a whole number, just put it over 1. All right, my y-intercept is 1, so that's nice and easy right there. Now, my gradient here is negative. So whenever you get a negative gradient, what you need to do is instead of going up, you're going to go down. So my rise over run is 3 over 1, but instead of going up, I'm going to go 3 down, 2, 3, and then 1 across for the run. Okay, so there's my line. Oh, my 2 points, sorry, and then I'll draw my line. Beautiful. Next one. y equals x minus 9. So in this case, remember, the y-intercept is the number by itself, which is negative 9. And then the gradient, okay, remember there's a 1 in front of that x, so it's 1. And if it's a whole number, just put it over 1. In this case, the y-intercept is negative 9. So where's negative 9? Well, on the y-axis, it's down here. Okay, down here. And then the gradient is 1 over 1. It's a positive gradient, so I'm going to go up 1 and then across 1. So the other point is there, and I can draw my line. There you go. Easy. And the last one is for x. In this case, my y-intercept, I don't see a number by itself, so it has to be 0. My gradient, okay, it's that number with next to the x, so it should be 4. It's a whole number, so put it over 1. So my y-intercept is 0. And my rise over run is 4. It's a positive number, so I'm going to go up 2, 3, 4, and then go across 1. Right, so from there, do 2 points and join the line. Lines are horrible, but there is your graph. Easy. Now, the other method that we're going to look into is what we call the intercept method. Now, the intercept method is another way to graph a linear graph, or linear relations that's got 2 plot points. The two solutions that are easy to find are the x and the y-intercepts. Okay, so we're going to find the x and y-intercepts because most graphs will definitely have an x and y-intercept at some point. An x-intercept of the graph is the x-coordinate of the point where the graph again crosses the x-axis. At this point, what should the value of y be? So for the x-intercept, whenever you look at the coordinates, the y is always going to be a 0. Okay, so for x-intercept, it's going to be whatever the coordinate is, but y is always going to be 0. Okay, for the y-intercept of a graph, the y-coordinate it's on a point on the y-axis. Okay, and at this point, what's the value of x? It's always going to be 0. So depending on the intercept you're looking at, for the x-intercept, y equals 0. For the y-intercept, x equals 0. Okay, so we can create a graph using the coordinates of the x and y-intercept. To find the x-intercept, we change y to 0. To find the y-intercept, we change x to 0. Hopefully that's not confusing, but it will make more sense in these examples. So find the x and y-intercept of this equation. Okay, let's do that. So firstly, remember, if you're looking for the y-intercept, you've got to change x to 0. So in this case, let's change x to 0 by doing the formula. So changing the equation where x now it becomes 0. So y equals 2 times 0 minus 5. Y equals 2 times 0 is 0. Take away 5. So that means y equals negative 5. Easy. So the y-intercept is negative 5. Now in that scenario, remember, if your y-intercept is negative 5, the coordinates are going to be 0, negative 5. Because for your y-intercept, x is always going to be 0. Okay, remember that's x, that's y. Right, for the y-intercept, same scenario, but instead of changing x to 0, we're going to change y to 0. So it's going to be 0 equals 2x, take away 5. Okay, now I'm going to do something a bit different here. I'm going to just switch this around to make x on this side by just doing this. 2x, take away 5 equals 0. Now, that's actually exactly the same thing, isn't it? Okay, they're exactly the same thing. I've just made it a bit simple by switching, flipping it around basically. This way, x is on this side, which I think makes it a bit easier to solve this. So we've done this before. We're going to solve for x, so we're going to isolate x. Get rid of that. Minus 5, it becomes plus 5. So you're left with 2x equals 5. Lastly, that x needs to be isolated, so we get rid of that 2. Here it becomes divided by 2. That's a times 2, remember. So therefore x is 5 over 2 or 2.5. Therefore, for the coordinates, okay, for the x-intercept, it's going to be 2.5 at 0. Because remember, for your x-intercept, y will equal 0. Okay, so let's draw this. Y equals 2x minus 5. You know, remember your plot points. Oh, actually, I forgot them. 0, negative 5 for the y-intercept, and the other one is, 2.50. So 2.50. So this is the y-intercept, and this is the x-intercept. So let's plot them. 0, negative 5, so it's going to be 0, negative 5 down here for the y-intercept, and then for the x-intercept, it's 2.50. So it's 2.5 right there, 0. And from there, nice and easy, join the dots. Okay, and there's your graph. Yeah, easy. All right, let's do it for these ones. Find intercepts for an equation not in gradient intercept form. So we're just going to find, basically, we'll do the same thing as what we did before. All right, so in this case, we're going to change x to 0 to find the y-intercept. So in here, it's going to be 6 times 0 plus 3y equals 24. 6 times 0 equals 0. So you're left with 3y equals 24. Now, isolate that y. That's a times 3, so it becomes divide by 3. Y equals 8. So therefore, the coordinate here, in this case, because x is 0, 0, 8. That's my coordinate. Oops. Next one here. Okay, same thing. I'm going to find the x-intercept. To find x-intercept, change y to 0. So it's going to be 6x plus 3 times 0 equals 24. All right, 6x you can do. 3 times 0, you're gone. Yep, will basically equals 0, so you can leave it. Equals 24. That 6 times x, got to isolate x. It's a times 6, so here it becomes divided by 6. Therefore, x equals 24 divided by 6 is 4. Okay, so that means your x-intercept coordinate is 4, 0, because y equals 0. So 4, 0. Graphing that, 0, 8. So it's going to be 0, 8. And then 4, 0. All right, so graphing that, remember, this is my y-intercept. This is my x-intercept. So y-intercept is 0, 8. So 0, 8 right there. My x-intercept is 4, 0. So 4, 0 right here. And then we put our line through 2 dots. All right, worked example number 3. Decide if the point negative 1, 4 is on the line with the given equation. So what we're going to do here is we're trying to figure out if this point is going to be in the line by substituting x and y values into an equation. So remember, this coordinate is an x and y coordinate. Okay, what we're going to do is substitute it into an equation, and if it makes sense, then this point is on the line. Okay, so for example here, we're going to substitute our point negative 1 and 4 into this equation. So change x into negative 1 and then change y into 4. So in this case, it's going to be 4 equals negative 2 times negative 1 plus 2. All right, solving that. So in this case, 4 equals negative 2 times negative 1 actually gives you 2, right? Plus 2. Which means 4 equals 2 plus 2 is 4. 4 equals 4, which means that the equation is true. And that means that, ran out of space there, negative 4, 1 is on the line. Okay. Special lines with only one axis intercept. So some of these ones you've seen before. So a horizontal line where is a line where it's obviously just like this, where it only has a y-intercept. So you basically just see y equals c. You'll see that if the line's just straight and you've got a number by itself for the equation, y equals 2, for example. If that's the case, the line will be there. You've also got vertical lines. where you've got x equals k. Now, don't get too scared of the letters. When you see x equals 5, for example, that means it's just a vertical line like that, where it hits 5 on the x-axis. Okay. And you also see some lines where there are no y-intercepts, so it just passes through 0. In that case, your formula will be y equals gradient x, and then that's it. Okay. And it'll always pass through 0 because there is no y-intercept. And that's it for this exercise. So I'll get you guys to do chapter 1F in page 39. Thank you.